Hello and welcome to 100 Random Tasks. I'm your host, Philip Lett, and on today's video I'll be reviewing this breadboard power supply that I picked up on AliExpress. If you like this video, please leave a like and a comment, and don't forget to subscribe to be notified of future videos. So I picked up 5 of these for just a couple of bucks shipped to my house, and it amazes me just how cheaply items can be mass-produced in China these days. For comparison, for me to ship this very item internationally from Canada, shipping alone on this is on the order of $10. And I looked up on DigiKey for the barrel connector here, and the cost is 72 cents each on quantities of 1,000, equal to the cost of this ready-to-ship board. It's easy to see why the hobby market just isn't what it was. There was a time when a hobbyist could make something like this and sell it from his house and collect a few bucks for his time. Now it's entirely not worth it when it can be had nearly for free. So let's go ahead and check the outputs on this first. This particular unit has 2 outputs, 5 volts and 3.3 volts, and it has 2 power sources. First is a USB mini, and the second is a 5.5 millimeter barrel jack. So we'll start with the USB mini and we'll see what our output is. So I have the top one here set to the 3.3 volts. You can see it's pretty much bang on 3.3. The 5 volts sitting at about 5.1. Now the 5.1 volts is coming directly from the USB connector and isn't going through the regulator at all. So let's see what happens when we put our barrel connector on instead. Now in this case we have exactly 5 volts. So you can see that the 5 volt supply that I have coming through the USB, it's not quite 5, it's a little bit on the high side, but still it's only 2% off, which is adequate. So I took a few minutes to actually draw the schematic out on this particular unit. It's very simple. So it starts off with the barrel connector goes through a diode, which prevents reverse polarity, through the 5 volt regulator, which then feeds a 3.3 volt regulator, and then out to our connections of our outputs. And we can select which one each output is, either 5 volts or the 3.3 volts. Now the USB bypasses the 5 volt regulator completely and goes directly into the 3.3. And then that's also connected through an LED to tell us that it's on. So the big caveat with this particular board is the power usage. How much power can we get out of this particular unit? So they've decided to use SOT 223 packages for the regulators here and here. So the thermal resistance between the junction and ambient, which is the key one, because they don't have any room on here for a heatsink of any kind. So we're limited with the worst case scenario for these particular parts. And that's about 135 degrees Celsius per watt. Now these also have a maximum junction temperature of 125 Celsius. So if you do the math for the power, that means that each one of these can dissipate 0.74 watts. So we take our 125 maximum temperature, subtract our ambient of 25, and we divide that by our resistance, and it gives us about 3/4 of a watt. So how much current is that actually? If we look at just the 3.3 volt regulator, which is here, then we take our 3/4 of a watt, and then because it's being dropped from the 5, we only have 1.7 volts being dropped across the regulator. So if we take the 3/4 of a watts, divide that by the 1.7 volts, we can draw a maximum of about 400 milliamps before this will shut down or release the magic blue smoke. Conversely, the 5 volt has 2 situations because the input voltage is rated between 7 and 12 volts according to this board. So if we do both cases, at 7 volts, we have a maximum current draw of 0.37 amps. And at 12 volts, we have a maximum current of 0.1. So unless you're dealing with some very low power items, using the barrel connector is not the way to go. The big caveat here also is the fact that the 3.3 is driven from the 5. So which means that even though our 3.3 maximum is 0.4 amps, we can only really draw 0.37 if we're using a 7 volt adapter in the barrel adapter. If you're using a 12 volt, then our maximum is also going to be 100 milliamps. So I would recommend that you don't use the barrel adapter unless you don't have access to a USB. So if you have a USB power connector and say it's rated at 2 amps, you're good to go. So you can pull your 400 milliamps directly through the USB, no problem. Plus if it's 2 amp, then you can also draw another 1.5 amps through the 5 volt side as well. Overall, I would say this is it worth the money? Yeah, I'd say it's worth the money. I mean, it's less than $1 shipped to your house. The build quality is decent. There's a few minor issues, but you know what, overall, considering it's $1, it'll work just fine for what you need it to do. It's clean. It's if you need a little more filtering, that's easy to do on your breadboard. So I would say this would be something to get. Now there are other options. A few other breadboards that I've seen, power supplies, that are a similar idea. They're a little bit different shape. They have some different connectors and things, and they're just as inexpensive. So any of those will work quite well, I think, for any of your experiments. So that's about it for this. Short video, quick review. Let me know what you think in the comments, and subscribe for future videos. See you next time.